Alright, so this is the last section of organics, and this is a very simple section. Again, if you take organic in college or if you take AP chemistry, like we said before, you'll get a lot more information about these, but all we're really looking for is just so that you've seen them before and you kind of know a couple things that they do. So the last thing we're going to look at is a thing called functional groups, and functional groups are basically when the carbons bond in special ways and they actually change the function of how something acts. So all you have to be able to do with these is be able to pick them out. Like if I show you them, that you would know, oh, this is this or this is that. So it's not a lot of information on it. So the first one is an alcohol. And a lot of times in organic we use an R, and it's not like there's not another element or something that starts with R. It's just saying that this could be any amount of carbons. This R could be 1 carbon, it could be 37 carbons. So we have carbons, and then if you're an alcohol, you have an OH group. And the OH group is our hydroxyl. So this is an example of an alcohol. And then phenols are just a very specific example of them. What you have is you have your benzene. So let's draw our 6-member ring. Oh, it didn't like me there. And you have your double bonds alternating. And then if you're a phenol, you have that hydroxyl group coming off of one of the carbons. So very similar, it's just that alcohols can be like kind of anything, and phenols are kind of a specific example. Alcohols are used a lot in gas additives. It's also the alcohol that people drink is ethanol. Just so you know, there is a difference between the ethanol that people can drink and like lab-grade ethanol. Lab-grade ethanol is denatured. If you would drink lab-grade ethanol, you could die from it. So it's not something you want to mix up at all. I mean, you can die from regular alcohol as well. It's used as antifreeze, and that's ethylene glycol, and it's used as a lot of skin softeners. And then phenols, which is this, if you ever have that chloroseptic spray that you use when you're not feeling so hot, your throat hurts, this is the only ingredient. The phenol is attached to your throat, and it actually makes you not feel pain for a little bit, which is kind of nice. Second one is an ether. So we're going to have 1R group, because again, that could be any amount of carbons. There is an oxygen, and then there is another R group. And again, I'm just going to write an R prime, because it's just saying that this R group does not have to be the same as this one. So basically, you could have a lot of ones. I'll draw one that I like. This is an ether I enjoy, and I'll tell you why in a second. The reason why I like this ether is the common name for this ether is his name is methyl ethyl ether, which I think is pretty cool. Ethers are used primarily as refrigerants, and you can make it from a condensation reaction. So what you do is you have 2 alcohols, and I'm going to draw the exact same alcohol twice. I'm just going to have one flipped over. So this is my first alcohol. I'm going to add it to the exact same alcohol flipped over. So this is a mirror image of the first. Now this is a dehydration reaction. So when you condensation reaction, either one you want to call it, when you think about that means you get water. So what you can see here is we pull out a water. So these 2 molecules come together, and to make water we need 2 H's and an O. So one of our products is water. And then what happens is these ethers were kind of ripped apart here. So what happens is this guy's kind of hanging out by himself, this guy's kind of hanging out by himself, and what they do is these guys come together and attach. So my other product is an ether. That's pretty easy to make. And again, like if you take organic chem, you'll learn tons and tons and tons of reactions, which is what makes organic chem fun. Aldehydes and ketones are pretty cool. You may want to just give yourself a hint on this. Let me just something I can actually type with. Aldehydes are on the end. Ketones are in the middle. So these are very, very similar, but because aldehydes are on the end, they're going to be more reactive. So you may want to give yourself a note. They are more reactive. And ketones are less reactive. But again, we'll use our lovely R's to just give you an example. So the first one we'll do is we'll do an aldehyde. So I'm just going to actually draw one. I'm just going to use an H to kind of show that I really am on the end. I have a carbon and I have an R group, so that I have no idea how many other carbons there are. But when you have an aldehyde, you have a double bonded oxygen hanging off. And again, it's on the end. Let me just actually make that kind of look like more like an O. So this double bonded oxygen is kind of hanging off the end, and it's going to be more reactive. Whereas the ketones look exactly the same, but they're just, or very close to being the same. They're just not on the end. So for a ketone, it's going to look literally the same. It's just that I have, let me write an R that you can actually read. I'm going to have a carbon in the middle here. I don't know why my pen doesn't like writing there. And we're going to have another R group over here. So there was not a hydrogen, which means we're not on the end. And we have the same double bonded oxygen. So again, they're very close. It's just placement. And they act different enough that they get different names. Aldehydes and ketones have a lot of good smells to them. So these are your spicy smells. So they're used extensively in perfumes. You can make them pretty easily from alcohols, very similarly to how we made the ethers. So if you like the way vanilla smells, you like cinnamon smells, you like aldehydes and ketones. And if you've ever actually been you like the way someone smells, your sex hormones are naturally occurring aldehydes and ketones. And there's actually some research that shows that you actually are biologically more likely to like someone that you could mate with effectively. I know that sounds a little interesting, but you actually could like the smell of someone. So there you go. That's your weird fact for the day. Carboxylic acids are kind of, it looks like two things put together. So what you have is you have some carbons, and then on one carbon, it looks almost kind of like a little boot when you have it all. You have a double bonded oxygen, but that's not it. Like on aldehydes and ketones, that's all you have. On that same carbon, you have an OH coming together. So this whole thing, the COO and H, is what makes it the carboxylic acid. So if on this carbon you don't have both of these, you're not a carboxylic acid. And carboxylic acids are the most common thing because they're your amino acids. They're what makes up your DNA. They make up your proteins. So all that kind of fun stuff. Esters look like carboxylic acids who are not on the end. So carboxylic acids always end in an H here. You can see this. Esters are basically just stuck in the middle here. So we have, oh, that's not what I wanted. Let's get an actual color here. We have an R group. You can ignore that yellow, that means nothing. You have your carbon. You have your double bonded O. You have a single bonded O, but then instead of having it just attached to an H and be the end, it's not, and you actually have another R group. You have more carbons here. So it's like a carboxylic acid stuck in the middle. Maybe I'll just get it. I don't know why I did 2 primes. But again, the R and the R prime just mean they're different. They could be different amounts of carbons. Esters are naturally occurring, and they're your fruity smells. So they're used a lot to make things. You store esters in your fats. So your body is very good. This contains a lot of calories, and esters are one way that your body stores that. But any fruit smells, any flower smells, are esters. And you can actually, it's really weird, you can make esters in little test tubes. It just requires weird chemicals. And you can hold it up to your mouth or to your nose, and you would swear it was a rose, or you can smell an orange or stuff like that. And it's really just these weird chemicals that occur. Amines have nitrogen in them, And basically what you have here is you have a nitrogen, and it can bond to three things. Amines are in amino acids, and we have the aldehydes and ketones that are spicy. We have the esters that are floury. Amines smell like decay. So, like when a body decays, hopefully you've never smelled this, but if something decays, you have the amino acids breaking down, and what they release are amines, which are nasty smelling. And your very last one for organic is an amide, and an amide is like a complicated amine. So it has a nitrogen in it. So you have an R group, you have some carbons, and then on one specific carbon, you have a double bonded oxygen, and then you have a nitrogen, and then that nitrogen can bond to some things. It could be hydrogens, it could be carbons, but the key here that makes it an amide is this double bonded oxygen, that's carbon, and the nitrogen. And a common amide is Tylenol. If you've ever taken acetaminophen, it's an amide that you have. And again, proteins, all that kind of stuff. So again, you don't have to know like the backstory of every functional group. You should read the chapter in your book on these and take additional notes. But what you really need to be able to do is pick them out, know what they are, and know what they're used for.